Hey everybody, this is day 13 of our meteorology unit, and in today's video I'll be covering air pressure field maps. We'll be going over some key understandings before taking a look at a couple of Regents questions for practice. So when looking in an air pressure field map, remember that these lines are called isobars, and they're connecting all of the points that have a weather station that are registering the same barometric pressure. So when we connect areas that have the same barometric pressure, we can identify some patterns, and meteorologists can use these maps to make predictions and forecasts about the weather. So a couple of key understandings that are related to air pressure field maps. Remember that wind is always going to blow from a high pressure to a low pressure. And when looking at the isobars in one of these field maps, the proximity of the isobar lines are going to indicate wind speed. So if the isobars are close together, an area will be experiencing high surface wind speeds. And if the isobars are really spread out on the map, it means that the area is receiving relatively low wind speeds. I really like this saying when remembering air pressure movement around high pressure and low pressure areas. I really like saying it in my classroom when I can point up at the clock on the wall and I can knock on the counter. Like when you put your drink on a counter, you put it down. So the clock is high and the counter is low. So what that means is that in the northern hemisphere, we're going to have air moving clockwise around a high pressure area. So the clock is high, and the air is going to be moving in a counterclockwise direction around a low pressure area. So the clock is high, the counter is low, and there is also some inwards and outwards motion. So as air is lifting up at a low pressure area, that's going to cause the rest of the air to move inwards. So that's why at a low pressure area, it moves inwards and counterclockwise. And then as the air comes down, creating a high pressure area, after it reaches the surface, it's going to be spreading out. So that's why at a high pressure area, we see clockwise and outward motion of air. So let's take a look at some Regents questions by applying these key understandings. We'll start off with a couple easy ones. So we see here a field map showing some isobar lines, and question 66 from the June 2018 Regents is asking about evidence shown on the map that indicates the highest wind speeds occurring near Watertown, New York. So remember, wind speeds, we can just take a look at the proximity of the isobars, and the evidence here that Watertown is experiencing the highest wind speeds is just that the isobars are close together. The opposite would apply in question 17 from January 2020, Earth Science Regents. At which location is the surface wind speed the lowest? That would be location C, because we see the isobars spread out over here. So I think the trick question, they were trying to find someone that would say point A because they're close together. Remember, if it's the lowest, we're looking at where the isobars are spread far apart. All right, let's take a look at two questions from the January 2016 Regents Exam. So in this question, we're looking at field maps showing the air pressure on two different dates in the eastern United States. So we're going to take a look at question 37 and 40 as they relate to these maps. So 37, which map shows the general surface wind pattern around the high pressure system on December 8th? So here's our high pressure area. And remember, during a high pressure area, the clock is high, the counter is low. So we're going to expect the winds to be moving in a clockwise motion. That's the same direction that a clock moves. So it looks like choice 1 could be a possibility, choice 2 no, choice 3 no, and this one does look like it's moving clockwise. So next we want to figure out, is it moving inwards and upwards, or is it moving downwards and outwards? Well, if it's a high pressure area, it must be moving downwards, creating that pressure. So we're going to see these lines moving outwards and clockwise. So the best option here would have been choice 4. So they're moving clockwise and then they're moving out from that center. Let's take a look at one more in this series. So question 40 asks, which information shown on the weather maps best indicates that wind speeds in New York State were greater on December 9th than on December 8th. Well, looking at this map, here we see New York with not many isobars around it. Here we see New York with many isobars around it. So due to that proximity, that would mean that the wind speed is higher. So the best choice would be choice 1. The isobars were closer together on December 9th. Okay, this question's from the January 2019 Regents. Question 66 is asking us to draw the 1000 millibar and 996 millibar iso lines. So I did this in a video last week on how to draw isobar lines, but we'll do this nice and quick. So remember, first we want to identify all of the places that have this value that we're looking for. So I want to find all the 1000 millibar lines. So there's one, there's one, there's one. I want to make sure that I find all of them on the map so that as I make them, I don't have to go back. And it looks like I have all of my 1000 values. So now I want to find how to draw this line by figuring out what two numbers is 1000 in between. So it is in between 1002 and 996, so I can go between those two lines. It is in between 1002 and 998, so before I make a straight line to this 1000, I have to make sure that my 1000 millibars is going where it needs to be. So it's going to be between these two numbers. 1000 is in between these two numbers. And now I have no other pieces of data that I need to work with until I go through 1000. Next up, what am I going to go in between? Not over here, but I'll go in between 997 and 1002. I'll go through 1000. I'll go between 998 and 1004, through 1000, through 996 and 1002, through 999 and 1001, through 999 and 1002. I'll go through 1001, 997, through these two, and then lastly, I'm just going to close off that loop. So around a high pressure system or a low pressure system, we'll usually see circles, closed circles surrounding those, not concentric because it's not the same center. So next up, 996, I have to go through this point here, through this point here, and I want to make sure that I'm not missing any. So I can't go straight to unless it allows me to, so I can go between these two numbers. I can go between 993 and 998, go here, between 995 and 999, through these two, and right back to 996. So there's my isobars for this map. 67, which location on the map has the greatest wind speed? And give us one piece of evidence that indicates. So we have W, X, Z, and Y. So I'm looking for the greatest wind speed, which would mean where it's the closest together, the isobars closest together. So that would be point X. 68, the weather instrument used to identify air pressure or barometric pressure. Remember, these are called isobars. BAR is associated with pressure. A barometer measures air pressure. Two characteristics of the general wind surface circulation pattern associated with this low pressure system. So remember, the clock is high, the counter is low. So it's going to be moving counterclockwise and inwards, because for low pressure, it's going to move in and then it's going to go up, kind of like a vacuum. One air mass associated with this pressure system originally formed over the Gulf of Mexico. The two letter, well, if it's forming over the Gulf of Mexico, I know it would be maritime because it's forming over the water, and tropical because it is forming close to the tropics, or it's a warm air mass. Okay, let's take a look at one more question. I like this one from the August 2017 Regents, and I want to look at question 38. So it says here, which map best shows the locations for the centers of high pressure and low pressure? So here we really just want to indicate, first off, those circles are going to indicate where that pressure system is, because remember, we have closed loops around pressure systems. So over here, 1028, this one is higher than all of my other values. So I can infer that my high pressure system is going to be there. And then over here we have 1008. That's much lower than all the other values here. So I know that that's my high pressure system. That's my low pressure system. And look at the answer choices here. It looks like I forgot one spot up on top. 1032. Well, this is relatively higher than the isobars around it. So then that's going to be a high pressure system there. So the best answer would have been choice 1 for this one. Okay, hope you enjoyed this video. I'll see you guys next time.